Alrighty, so today we're going to be learning about average atomic mass. So the first thing we need to talk about is what is an isotope? So let me read you what this says. An isotope is one of two or more species of atoms with the same atomic number. Okay, they have nearly identical chemical behavior, but they also have different atomic masses and physical properties. Every chemical has one or more isotopes. So let me show you the Miss Kaminsky isotope. So when I was about 4-ish, I suppose in this picture, I weighed about 35 pounds. Okay. And then when I graduated high school, I weighed about 130 pounds. And now today, I weigh 150 pounds. These are all me. Miss Kaminsky at different ages, different stages in my life. But I have a different mass. I have a different weight. That's the same thing as an isotope. Just imagine me as an element. But let's look at a real chemistry example. And we're going to look at zinc. You can see down here, it says 65.41. This is measured in AMU, atomic mass units. So atomic mass units. It's how we measure the atomic mass. This number is not actually the truth. It is an average of every isotope of zinc that has been discovered. So it's an average. It's not actually how much zinc weighs. Now let's talk about this number 30. 30 is the atomic number. And if you remember a second ago, we said, let me go back, isotopes, let me get a new color as well. Isotopes have the same atomic number. So again, every person in these pictures is named Miss K. All right. It's always going to be named zinc. And the reason why is because of the atomic number. Atomic number tells you what the element is. So, recap. We measure atomic mass in AMU, atomic mass units, and it is an average of all the isotopes. And it's going to have the same atomic number, meaning the element does not change, just the mass. So we have something interesting here. We know atomic number is equal to the number of protons. And as we said, it's always going to be zinc. Atomic number of zinc is 30. That means it has 30 protons, no matter what. However, mass changes. So what's mass? How do we calculate the mass of an atom? So, atomic mass is equal to protons plus neutrons. Protons don't change, so we're good there. What's left? Neutrons. Neutrons change between isotopes. Okay, so let's solve an isotope average atomic mass problem. This says, calculate the average atomic mass of lithium, which occurs as two isotopes that have the following atomic masses and abundances in nature. 7.30% at 6.017 AMU and 92.70% at 7.018 AMU. Okay. Now, we know there are two isotopes because that's what it told us. There's the first one. Here is the second one. Remember, atomic mass is AMU. So whenever you see AMU, we're talking about mass. And then abundances is percent. What percentage does it occur? Okay, so when you see a percent sign, that means abundance. Step 1 is to convert your percentages to decimals by dividing by 100. That's step 1. So our first percentage is 7.30%, and we're going to divide by 100. And that equals 7.30 divided by 100, 0.073. All right. Now let me show you a shortcut with the second one. Our second percentage is 92.70%. Now, you can continue to divide by 100. That's totally fine. However, the shortcut is moving your decimal over 2 places to the left. So 1, 2. All right, and we're just going to rewrite it. So that is 0.9270. It's the same thing. So there's just a little shortcut. All right, so that is step 1. Let's move on to step 2, which is the formula. So our formula is average atomic mass is equal to your decimal. So that percentage that you turned into a decimal times the mass plus the decimal times the mass, and so on and so forth, depending on how many isotopes you have. So let's plug in our values. AAM, average atomic mass, for lithium is going to be 0.073 times the mass, 6.017. All right, plus our second decimal, which is 0.9270 times the mass right here, 7.018. Okay, and I'm sure y'all love and remember fondly PEMDAS. First thing we're going to do is take care of our parentheses. So let me get out of this. I'm going to keep my annotations. Let's go to our handy dandy calculator. Okay, so we got 0.073 times 6.017 equals. All right, so we have 0.4392. Okay, and then now let's calculate the second one. So it's going to be 0.9270 times 7.018 equals 6.505. All right. And then now we can add. Plus 0.4392. All right, so our final answer is 6.944. And it is AMU because we are calculating average atomic mass, and atomic mass is measured in AMU. All right, so that is your final answer. I hope that helps, and I will see you guys next time. Bye bye.